This video will cover the topic of percentages as equation solving. Be sure the date and topic are at the top of your page. The essential question of this video is, how do we calculate percentages as equation solving? By now, we know that when we want to find the percentage of something, that we can generally use multiplication as a strategy. So for example, what is 15% of 90? We know that 15% means the same thing as 15 hundredths, and so we can write that as 15 hundredths, and of tells us to multiply. And when we do that, we end up with 13 and a half. What we might not realize is that we are setting up and solving an equation. And the equation that we're essentially solving is the percent times the whole will tell us the part. But as we work with an equation, I'm actually going to use a different word instead of part. I'm going to use the word quantity instead, and that's just because I don't want two parts of my equation to be starting with the same letter. So I'm going to think to myself, well, percentage times whole equals quantity, so P times W equals Q. That's the equation that we've essentially been solving all along. Let's see if we can use that equation to help us solve different types of questions. So in this one, we know that 35% of students here take the bus to school, and there's 600 students total. The question is, how many take the bus to school? To do this, we have to kind of dissect what we know a little bit. So I know that I'm trying to do percentage times whole equals that quantity that take the bus to school. So we certainly know our percentage here. That's our percentage. We know our whole. And what we're looking for is our quantity. That's what we don't know. And as I work to kind of use my equation here, remember that 35% is really 35 hundredths. And we know our whole is 600, and that will tell us what our quantity is. So we'd go ahead, this is pretty straightforward, we'd punch that in, calculate it to the side, and we would find out that when we multiply, there are 210 students. Sometimes, however, you know different parts of the equation. So in this example, I'm still going to be using my same equation, but when I read over the question, I know some different pieces. So at the restaurant, Zoe left 8% as a tip. She tipped 20%. How much was the bill? So I know her percentage, right? That's 20%, and I can write that as a decimal. I know that the percentage that she left, the quantity she actually left, was $8. But what we don't know was what the whole bill was. That's what's missing. So I'm going to fill in what I know here in my equation. So I know the percentage, I put that in as a decimal. I don't know the whole, so I left that variable there. But I know that the quantity she left was $8. So this is just now basic equation solving. I have something times my variable, so I'm going to undo it by dividing on both sides. This, of course, will cancel itself out. And when we do 8 divided by 20 hundredths, we get 40. That means the bill must have been $40. So I still use the same equation, but I knew different pieces, and so the approach I took was a little bit different. Then again, we could see something like this, right? So again, I'm going to use my same equation, but let me see what it is that I know. So I know a shirt is regularly $40, so that sounds like that's the whole. But I also know that the quantity right now is just $18. What I don't know is this percent. That's what's missing. So I'll fill in what I know and I'll solve. And it's going to look a little something like this, right? So I have P times 40 equals 18. Well, to undo that, I'm going to have to divide. And I'm going to do my division on the side again. And when I do that, I find out that P is equal to 45 hundredths. But of course, I actually want to turn that into a percent. So when we do that, we multiply by 100 or move that decimal twice. So we actually get 45%. And again, it was just a matter of filling in what I knew and solving for what was missing. But sometimes these can get a little bit more complicated, and I'll just show you one complicated version here, and then maybe we'll do some more practice together in class. So here's an example of a tricky question. You might not look any different from the outside, but when we read it carefully, we might notice the difference here. So Columbia Sportswear has a sale of 25% off coats. And with the discount, the price of the coat that you're looking at is $34.50. So the question we're asking is, what was the original price of the coat? And I'm going to still use my same equation, but let me see what it is that we know. So we definitely know already right from the outset what we're looking for is that whole price, right? We don't know that. We do know that this was the quantity that was left, right, when we had our percentage. And here's where it gets tricky. This 25% is not like what we saw in the example with Zoe's question, right? We knew that Zoe tipped 20% and that was $8. This 25% is not $34.50, right? That's what's left over after we take the 25% off. So this price here that we paid is what we paid when there was 100% and we took off 25. What we know is that that is the equivalent to 75% of the price of the coat. So that's kind of tricky. So we know that the 75% that we actually paid for, if we did 75% times the whole price of the coat, that would be the $34.50, right? 25% of the coat is not $34.50. That's not how much we saved. $34.50 is the amount that we paid when we paid the remaining 75% of the price. From there, once that's the trickiest part though. So from there, we're just going to do the same thing where we divide on both sides to get that variable by itself. And when we do that, I'm doing it on a separate piece of paper here. When we do that, we end up with our whole being 46. So that's kind of a tricky version of this where you have to think, wait, do I know 25% is the $34.50 or is that the 75% that I still paid? So you kind of have to think about that one. And we'll be working with this equation in class, but I want to show you this other visual in case it helps. So this is kind of the percent pyramid, and you can see here that the whole and the percent are next to each other, and when you know the whole and the percent, all we did was multiply to find that quantity. However, when we had to solve our equations later on and we knew the part or the quantity and the percent or the quantity and the whole, we ended up having to divide to solve for our missing variable. So that might be a visual that could help as well, and we'll be able to pull that back out in class and kind of see if that's a good strategy as well. But for now, just remember that the essential question of the video was how to calculate percentages as equation solving, and hopefully this kind of gave you a quick little snapshot of different ways that you can see this equation and how you can fill in what you know to solve for what is missing. Be sure to have your notes and questions ready for class.